The test you just witnessed was carried out by none other than Honda, a name long associated with precision engineering in cars and motorcycles. Now, Honda is charting a bold new course in aerospace with the successful trial of its first ever rocket. What's drawing attention isn't just the milestone itself, but how closely the rocket's design mirrors the architecture of SpaceX's reusable systems, signaling the arrival of a surprising new contender following a familiar, proven path. So, how did Honda make this leap from roads to rockets? What elements of their design echo SpaceX's innovations? And what does this mean for their future in such a competitive field? Let's break it all down in today's episode of Great SpaceX. When people talk about Japanese aerospace, the focus is usually on the Japan Aerospace Exploration Agency, aka JAXA. This includes well-known rockets like the H-2, H-3, and more recently, lunar missions such as SLIM and Resilience. However, Japan's private aerospace sector is beginning to grow rapidly, following in the footsteps of leading spacefaring nations like the United States and China. One of the most surprising and promising names to emerge in this trend is Honda. The test seen at the beginning of this video marks a major milestone for the company. It was Honda's first rocket test and took place on the 17th of June at their facility in Taiki, Hokkaido, which is widely known as Japan's Space Town. This type of test is formally known as a vertical takeoff and landing test, or VTOL. These trials are designed to examine both the launch and landing capabilities of new rockets, particularly those being developed for reuse. Honda has been planning this test since 2021, following the success of their earlier reusable engine tests. By all accounts, this was a highly successful start. The rocket fired for 56 seconds, reached an altitude of 271 meters, and landed with precision just 37 centimeters from the target landing pad. Every stage of the flight was well controlled, smooth, and clearly demonstrated a high level of technical proficiency. Honda later stated that they achieved multiple objectives across each phase of the test. Looking ahead, the company is aiming to conduct larger and more ambitious tests, including a suborbital flight planned for 2029. So how has Honda made such a significant leap in aerospace? While nothing has been officially confirmed, it appears that Honda's design has taken considerable inspiration from SpaceX rockets. Some might even argue that these similarities suggest elements of direct copying. To begin with, Honda's test rocket measures 6.3 meters in height and 85 centimeters in diameter. Its dry weight is around 900 kilograms with a wet weight of around 1,312 kilograms. These dimensions are small, but this is understandable since the current model is intended for basic flight and landing verification rather than full-scale orbital missions. The signs of SpaceX's influence become clearer when examining the rocket's systems. The most obvious similarity is the foldable landing leg design. SpaceX uses 4 landing legs on its Falcon 9 boosters that fold up during flight and deploy just before landing. Honda's rocket also has 4 legs, though they fold downward rather than upward. The purpose and function, however, are very much the same, to stabilize the vehicle during landing. Given Japan's access to the Pacific Ocean, this system could eventually support sea-based landings, much like SpaceX's use of drone ships. Another shared feature is the grid fin system. These fins, which help steer the rocket during descent, fold in when not in use and deployed to provide aerodynamic control and deceleration. This technology is employed by both Falcon 9 and Starship and now appears to be present on Honda's test rocket as well. In terms of construction materials, Honda seems to be using carbon fiber, similar to what SpaceX uses for some of its structures. The rocket's sleek white appearance is also reminiscent of Falcon 9's visual style. Looking at the rocket's shape, it closely resembles the upper stage of Starship with its long tapered nose cone and overall cylindrical form. The height-to-diameter ratio is nearly identical. The main difference is that Honda's design does not include the aerodynamic flaps used by Starship for controlled atmospheric descent. Given the similarities in shape and size, it is reasonable to suspect that Honda's rocket might eventually be paired with a booster stage. Another possibility is that it will use a combined configuration similar to Rocket Lab's Neutron, which features a single structure that performs both stages of the mission. Fuel choice also aligns closely with SpaceX's current strategy. Honda's rocket uses liquid methane, as indicated by the orange-blue flame visible during the test. SpaceX has championed methane as a future-forward fuel due to its cleaner burn, lower cost, and the ease with which it can be produced. Its environmental benefits and reusability make it especially appealing for modern rockets, and Honda appears to be following that same path. There may be other indicators of SpaceX influence as well, such as payload optimization for satellite delivery, possibly aimed at competing with constellations like Starlink. Another interesting parallel is the crossover between automotive and aerospace technologies. Just as SpaceX draws on Tesla's sensor and control technologies, Honda is likely to be integrating its own automotive expertise, including advanced sensors and precision controls, into its rocket program. While Honda's rocket does not copy SpaceX as directly as some Chinese models like the Zhuque 3, the influence is certainly present. This is not necessarily a bad thing. It shows that aerospace companies around the world are learning from the remarkable progress SpaceX has made in recent years. So what do you think? Given Honda's recent progress and promising first test, do you believe they can continue building on this success? Share your thoughts in the comments by responding with a yes or a no, and